Hello everyone, welcome to my second lecture on HVDC transmission. So previously we have studied about advantages of HVDC and today we will discuss about disadvantages. So the disadvantages of HVDC are high cost of DC breakers, okay, changing voltage level. Like in AC we can use transformer to change voltage levels, but in DC we can't use transformers because transformers works only in AC, okay. And to change the DC level we need DC choppers, which are more complicated than transformers. And high cost of conversion equipments. So like if you use HVDC we have to convert the HVAC to HVDC, and the conversion cost is high because we need rectifiers, filters, etc., and that cost money, okay. So it includes filter cost. Filter is what? Filter is for smoothing the output of the rectifier, because the rectifier output, we'll see in this further in this slide, that rectifier output is not plain but rippled, and to rectify those oscillations we have to use filter. And filter is what? Filter is combination of inductor and capacitor, and both those things cost money, okay. So this is another disadvantage of HVDC. And control complexity. So controlling the power level and voltage level is complex compared to AC. In AC we can use just one transformer to change the voltage level, but in DC we cannot. So these are the disadvantages of HVDC. But with the advancements over the years, the disadvantages have been minimized. Like the advancements are development of DC breakers, modular construction of thyristor valves, increase in the ratings of thyristor cells that make up a valve, 12 pulse operation of converters, use of metal oxide glass arresters, digital electronics, and fiber optics in control of converters. These things have minimized the disadvantages of HVDC, though it had not completely rectified it, like make it null, but it has minimized the disadvantages. Measures of reliability. So how reliable a HVDC system is compared to HVAC, we can get that by measuring their reliability, of HVDC system compared to HVAC. And to measure this reliability, there are two types of parameters. One is energy availability and second is transient reliability. Energy availability is the nothing but, as you can see, 100 into 1 minus equivalent outage time by total time, okay. So what is equivalent outage time? As you can see below, equivalent outage time is the actual outage time into fraction of system capacity lost due to usage, okay. So we subtract that from 100, and the ratio of equivalent outage time and total time, we subtract that from 1 and multiply it with 100, we get a percentage of energy availability, okay. Now transient reliability. Transient reliability is nothing but 100 into number of times HVDC systems performed as designed by number of recordable AC faults. And recordable AC faults are those faults which cause one or more AC bus phase voltages to drop below 90% of the voltage prior to fault, okay. So this is what transient reliability is. Next we have application of DC transmission. So what are the areas we can apply the DC transmission instead of AC transmission? One is long distance bulk power transmission, second is underground or underwater cables, third is asynchronous interconnection of AC systems operating at different frequencies or where independent control of system is desired. Fourth is control and stabilization of power flows in AC ties in an integrated power system. Okay, so here are a description of DC transmission systems. Okay, so DC transmission system means like HVDC transmission system or system. In how many ways we can use DC transmission system? Okay, so one is monopolar, another one is bipolar, and third one is homopolar. So let's see their configuration. So it is monopolar DC link, HVDC link. And what is monopolar? So on the extreme left and on the extreme right we have two bus bars, and those two bus bars are connected to the DC link in between with the help of transformer. Okay, so with the help of this transformer we are stepping up or stepping down whatever is required the voltages and converting, rectifying it into DC voltages with the help of converter and with the help of rectifier and filters. Okay, so on the left side we can see the direction of the arrow is downwards, and on the right side the direction of the arrow is upwards. And what is this symbol? It is a symbol of controlled rectifier. If there were no line on the anode side, then it would be simple diode, but as there is a gate symbol on the anode of this diode, so it is not diode, it is controlled rectifier, silicon controlled rectifier. And what we do with the help of this rectifier, we control the output power. Okay, so in this case, so for a circuit to complete we need a closed path, but in this case we can see that both on the left side and on the right side it is not a closed path, but it is grounded, and current is flowing from right side to left side. So as it is DC, on the right side the voltage potential is more, and on the left side the voltage potential is low. That is why the current is flowing from right side to left side, but it needs a closed path. So in this case what we can do, we can use earth as a closing medium, like the missing part. Okay, so monopolar link, as said below, monopolar link has one conductor usually of negative polarity and uses ground or C return. Sometimes metallic return is also used. Sometimes generally ground or C return is used. What is ground return? It means the left side the one part is grounded and on the right side other part is grounded, and we are assuming that as the ground is the same, so we can use the ground for the returning path of the current that is flowing from right side to left side. It need not always be ground, it can also be C. Okay, and sometimes metallic return is also used. Now we have bipolar. What is happening is bipolar, it is similar to monopolar, except we have just copied the above configuration and pasted it below. Okay, so again here on the extreme left and extreme right we have bus bars which is connected to the rectifier model in the middle with the help of transformer. Transformer are used to step up or step down the voltage level as desired, and then it is connected to rectifier. Okay, and in the left side both the rectifier directions are in the above side. Okay, and on the right side it is below. So the current is rotating through this circuit, and in this case the wire is grounded as like monopolar, this HVDC link, but as we are getting a closed loop path of our own, so we are not using, it is better to say the current is not using the ground for return because it has a closed path already. Okay, so it is, as it is said here, bipolar link has two conductors, one positive one and the other negative. Each may be a double conductor in EHV lines. Each terminal has two sets of converters. As you can see, the left terminal has two converters and right terminal has two converters in series on the DC side. So both of them are in series. The junction between the two sets of converters is grounded. Okay, so middle portion is grounded between above converter rectifier and below rectifier, or better to say converter, because why we are calling it converter instead of rectifier, because sometimes it can also be used as inverter for converting DC to AC. So one device is working as rectifier and inverter, that is why we are calling it converter. So the junction between the two sets of converter is grounded at one or both ends. Normally both poles operate at equal currents, and hence there is zero ground current flowing under this condition. Okay, because both poles have equal current, so the current that is going in is coming out, so nothing is going in the ground. Next we have homopolar HVDC link. And what is the difference between homopolar and the previous bipolar? So look carefully, the direction of the arrow of the SCRs. So on the left side we have both on the above directed arrows, and in the right side we have ground directed arrows. Okay, but in this case on the left side the direction of the arrow, one is towards the head and another one is towards the bottom. Okay, same case in the right side converter. Okay, so in this configuration what is happening is current is not rotating through the closed path, but there are two circuits, one above and one below, and current is in the below circuit. The current is flowing from right side to left side and getting back to the circuit, that is the closed path is the ground. Same case in the case of above circuit. Okay, the top circuit, the current is flowing and it is rotating using the ground as return path. Okay, and sometime metallic return is also used. So I have collected some data from Government of India Ministry of Power's official website. It is as mentioned here, https://powermin.nic.in. just write this address in your browser and you will go to official website, the Ministry of Power, and there you can see some data and look at those data. Okay, it is the 9th plan, like mentioned above, HVDC transmission system existing at the end of 9th plan and program for 10th plan, that is 2002 to 2007. It includes HVDC transmission, bipole, back-to-back monopole lines and terminal stations. So look at the left side of the chart, HVDC bipole line, Chandrapur, Padge, Rihand, Dadri, Talcher, Kolar, and the rating is plus minus 500 kilovolt. Okay, and PGCIL and others are in this the project. Okay, and as the end of the 9th plan. So you can get the details from this chart. Here bipole line, there is HVDC bipole transmission capacity, HVDC back-to-back transmission capacity, HVDC monopole line, HVDC monopole transmission capacity. Next, okay, so we have HVDC bipole line, HVDC bipole transmission capacity, etc. Okay, and now you have HVDC back-to-back transmission capacity. So look at this data to get a general idea of HVDC systems in our country. So what are the parts of this HVDC transmission line? One important part is converter station. You can see the picture, the diagram of the converter station on the right side. Okay, so it is used for AC to DC conversion as a rectifier station. It can also be used as DC to AC conversion as inverter station. So how do we convert, like shift from rectifier mode to inverter mode? Actually, we change the angle of the gate voltage that we are applying in these SCRs, and that changes whether it is used as rectifier or inverter. So it can be reversed by converter control, and which also reverses in power reversal. So let's look at the diagram and see what are these components. So coming from the left side, so there is AC bus on the left side, and after that we have this round symbols. These are transformers. Okay, and these transformers, the above one, the topmost transformer is connected in star mode. Okay, the star connection. After that we have star delta connection, after that we have star delta connection, and after that we have star connection. Okay, and after stepping up or stepping down, we have SCRs, that is converter station. We have silicon control rectifiers which are converting AC to DC. After that we have inductor and capacitor working as filter. And what is the inductor doing? Like number 3, I am talking about number 3. Okay, so number 3 inductor is called smoothing inductor, and number 4 filter is a DC filter. Okay, so smoothing reactor is nothing but series inductor, and the DC filter is a combination of capacitor and inductor in series, and after that we are getting the DC output as desired. So for HVDC transmission to work, we have to first convert AC to DC, and that is why we require converter stations. Okay, next we have 12 pulse converter unit. So what is 12 pulse converter unit? It is two 3-phase converter bridges connected in series to form a 12 pulse converter unit. So a 3-phase converter bridge contains 6 pulse converter unit, and 2 6-pulse converter unit makes 12 pulse converter unit. Okay, so above one is 3-phase and it has 2 SCRs, and below one is 3-phase, it has 6 SCRs, and both of them makes 12 SCRs. The total number of valves in such a unit are 12. Okay, and each valve is used to switch in a segment of an AC voltage waveform, and the valves are cooled by air, oil or freon. So what is freon? Freons are stable non-flammable moderately toxic gases or liquids which have typically been used as refrigerants and as aerosol propellants like CFCl3, CF2CLT, etc. So in this model, again on the left side we have AC bus, and then transformer, then converter unit, and on the right side we have DC terminal. Okay, and this is where we are getting the DC output. Now converter transformer. So converter transformers can have different configurations, like 3-phase 2 winding transformer, single phase 3 winding transformer, single phase 2 winding transformer. The valve side windings are connected in star and delta with neutral point grounded, and on the AC side the transformer are connected in parallel with neutral grounded. Next, filters. We have in converter stations or HVDC configurations, the filter we use are AC filter, DC filter, and high frequency filter. So AC filters, these are passive circuits used to provide low impedance shunt paths for AC harmonic currents. Both tuned and damped filter arrangements are used. In DC filters, these are similar to AC filter and used for filtering DC harmonics. Okay. So what is DC harmonic and what is AC harmonic? Like suppose we have our power supply in our houses, and which is generally 220 volt 50 hertz. So if it contains third harmonic, so it is AC in nature, but if it contains third harmonic, that is 50 hertz into 3, that is 150 hertz. So there will be signal like the voltage with 150 hertz frequency within this supply, and these harmonics are bad, like because of this high frequency inputs, the machines like generator or motors, whatever it is using, it get hot. Okay, heat is generated, and in DC filters the harmonics are undesired part of the input. So these are the difference between AC filter and DC filter. And next we have high frequency RF PLC filters. These are connected between the converter transformer and the station AC bus supply bus to suppress any high frequency currents. Sometimes such filters are provided on HVDC bus connected between the DC filter, DC line, and also on the neutral side. Next we have a reactive power source. So what are the reactive power source on the HVDC transmission system? One is converter station require reactive power supply. Okay, so converter station needs reactive power supply to operate, and that reactive power needs to be 50 to 60% of the active power supplied. Next, AC filter provides some part of the reactive power. Okay, so AC filter contains inductor, capacitor, etc., and it supplies some part of the reactive power. Next we have shunt capacitor, synchronous condenser, okay, static burst system, which also supply reactive power. Okay, so these are the source of the reactive power in HVDC's power system. So what is smoothing reactor? Smoothing reactor is also used to supply reactive power. So see the picture on the right side. The topmost picture is the output of full bridge rectifier or rectifier system. Okay, full wave rectifier, and this is the input. The topmost picture is the input. The second one is the output of full bridge rectifier or full wave rectifier, and the bottommost picture is the filtered output. Okay, so after using the smoothing reactor as the second picture, the middle one as input, we will get output as the bottommost picture. Okay, so that is the working principle or necessity of smoothing reactor in HVDC. Now DC switchgear. So what is DC switchgear? According to Wikipedia, in an electrical power system, switchgear is composed of electrical disconnect switches, fuses, or circuit breakers used to control, protect, and isolate electrical equipment. Switchgear is used both to de-energize equipment, to allow work to be done, and to clear faults downstream. This type of equipment is directly linked to the reliability of electric supply. Now, DC switchgear, it is one type of modified AC equipment. It is used to interrupt small DC currents. Okay, it is also used as disconnecting switch for example DC breakers, metallic return transfer breakers. In addition to AC switchgear and associated equipments are also used along with this DC switchgear. Okay, so thank you, that's for today. Have a good day.